Hey, Miss Sparks.
I'm just talking away at you, and my mute was on.
I figured it's okay.
I needed to get a pencil.
Okay.
I'm wondering, and I don't know if you mind being this, but I need that person that kind of helps me tell me if anything's in the chat window because unfortunately I can't see the
hmm
chat window when I'm on the PDF writing. Do
Okay.
you mind being that person?
No, I can let you know.
Okay, that would be great.
Okay.
And I'm also wondering, do you think the majority of the people want a review on the simple graphing? Or do you think everybody's good on that? And should I skip to the more complicated?
I think the simple graphing, everyone's understanding. I mean, it's like the easiest thing we've done so far, so I would hope they were understanding.
Yeah, it is. It is kind of the easiest thing for sure.
Yeah, definitely.
Um,
So do we have a test or a quiz tomorrow?
it's a test.
Awesome.
Yay. Well, let's see.
The only thing really that I don't understand in the slightest is the last thing that we've done.
Okay.
Yeah, because I have not a clue.
Well, I wonder if maybe I should just work through the review backwards.
Go for it.
You think?
That's what I usually do, honestly.
Is it?
I typically, like on tests and stuff, I'll flip over to the back and do it backwards.
Okay. All right. Well, I hate to get started since it's not quite 11 yet. So, but maybe I will. If I have to do them twice, I do them twice. It won't hurt. Plus, I've got to do them again at 1:30 anyway.
True.
Um, make sure I'm writing. I'm not. Okay. Looking at number 19, since that's where we'll start.
hmm
Um, the very first thing that you want to do is go ahead and get each of your denominators in simplest terms, because what you're doing when getting a common denominator is actually repeating each, making sure that each factor is actually included in that denominator. So the only one that really looks like it can be reduced any further is the 3a plus 6. And that would simply come down to 3 times a plus 2, which then the good news of that is I've got that here and I've also got that here. But what that also tells me is that my common denominator for this one that I will multiply each side is going to include a 3, an a plus 2, and an a minus 7. So all 3 factors on each side will be represented.
Okay.
Okay. Oh, that's nice. Whatever that is, that's nice. Did you see that? Or was it just?
No, sorry. I was working it out.
Oh, okay. And then I could hear Joshua joined us. Hey, Joshua.
Uh,
Um,
I'm gonna turn my camera thingy off.
oh, okay. All right. I don't blame you. I turned mine off.
Wait. Okay. There you go.
Wait, I think everybody almost turns them off, to be perfectly honest with you. We all have our special at home look.
No one looks good right now.
Okay, so, and I'm trying to also take note of who's here since the math labs were mandatory. this week. So, because I want to make sure that if they're not my students, that I'm letting Miss Stone know. So anyway, so now we've got our common denominator, if you will, for both sides of the equation. So now we'll kind of break it down. And what we'll look at is how many times will that 3a plus 6 go into this big, huge, quote unquote, common denominator. What would be left after we divided that out? And that's going to be your a minus 7 factor. So then you would take the a minus 7 factor, because this 3a plus 6 is essentially this right here. So you would take that a minus 7 factor, you would multiply it by this 1, and you're going to write it a minus 7. And once again, I have a tendency to always keep my things in parentheses till particularly when there's a subtraction, just because I want to make sure that all of my, distributions happen properly, because that's where some of those common mistakes can be made. So I'm going to keep everything in parentheses until I actually start combining my like terms on the left side of the equal sign. So now I've got this a minus 7, and how many times would it go into that big old factor that we have, or common denominator that we have, with what would be left? Well, you would have that 3 times a plus 2, or 3a plus 6. However you wanted to write it in this case is going to be perfectly fine, because you're only multiplying it by a 1. So it's essentially itself. So if you wanted to go ahead and put in parentheses the 3a plus 6, you'd be okay on that. Does that make sense?
Mm-hmm.
Yes.
Okay.
You want me to keep talking, or?
Sure.
Okay.
If I'm saying something, and like you see somebody write something in the chat box, they're like, "Wait a minute, Miss Sparks, slow back down," because a couple people have questions. That would be awesome.
Okay.
And people talking with me always kind of helps me know whether I should just keep barreling through.
Okay.
Okay, and then now on the right side of the equal sign, which is where we're addressing now, we've got the a plus 2 in our denominator. So what we're looking at is, okay, what is going to cancel out this time? And what's going to be left? And so your a plus 2 is going to cancel out, and it's going to actually leave you with 3 times a minus 7, which, once again, if you wanted to, you could write that as 3a minus 21. It doesn't, because obviously in the next step, you're going to have to do that anyway. And I'm going to go ahead and move all the way up to here and kind of finish my problem. So now I've got a minus 7 minus 3a plus 6. So this minus right here has to be distributed all the way through over here, okay? So I've got a minus 3a, which that's going to leave me with a negative 2a. Does everybody agree with that? Stop me if I make a simple math mistake. And then I've got a minus 7 minus 6, because this subtraction, once again, has to be distributed to that second 6 there, or that 6 on the other side. So minus 7 minus 6 is going to give me a minus 13 on the left-hand side. And then over here, I've got my 3a minus 7. Now it's a matter of actually, moving things around, getting my variable on one side and my constant on the other in order to solve.
This is the 3a minus, doesn't it equal 3a minus 21 since you...
Minus 21, yes, thank you. I appreciate you watching out for me. I said it before, but then didn't write it.
Okay, thanks.
Bless you. And so then I'm going to subtract the 3a from both sides. And that's going to give me a negative 5a minus 13 equals a negative 21. And then I'm going to add 13 to both sides. And then that's going to give me a negative 5a equals a negative 8. And then that's going to give me I'm going to divide then both sides by the -5, and then that's going to give me a positive. I'm going to write it over here. Sorry about that. It's going to give me a positive because I've got a negative divided by a positive, a negative divided by a negative, which is going to give me a positive. So I'm going to have a positive 8/5 A. And then once again, what we're going to want to do is kind of take a look, and is that going to do anything weird to the denominator in the original problem? And 8/5 is not going to cause a problem, so that's not going to have an extraneous solution. How is that?
How do you like know?
I'm sorry, say that again, Joshua.
How do you know if it's going to cause a problem or not?
Oh, how do you know if it's going to cause a problem? Great question. I'm just going to erase all this stuff all around 19 so we can talk about that directly.
Okay.
So that we can really look at the original problem. Okay, we got 8/5. And the reason why I know that it's not going to be a problem is if I stick in 8/5 at this A right here, that's going to be 8/5 plus 2, which really is going to give me 18 over 5, 18 over 5, because, because 2 converted to a common denominator, that's going to give me 18 over 5. That's not going to be a problem. How it's going to be a problem is if anything takes me to a 0 in that denominator. So in that case, a -2 would be a problem, 7 would be a problem, and a -2 over here would be a problem.
Just because you can't divide by 0, so you're just mad.
Yes, sir. That's it exactly.
Thank you.
Not a problem. Great question. So that's essentially what you're doing when checking for extraneous solutions. That's going to be your biggest thing to look for. And we did have a couple on the worksheet that we did on Tuesday, which I found out from a student in my class that if you weren't able to catch that and if you had any questions on that worksheet, there is a YouTube video of the actual math lab. Skip the first 10 minutes because that's me trying to post the link everywhere. So there's really actually nothing going on.
Okay.
There were a couple in that case where one of them didn't work because it made the denominator a 0. But I can't remember on this review sheet if that's actually the case for any of them. And one of the reasons that I'm starting in reverse and working backwards is to make sure it seems like most of the questions have arisen from, kind of in order from how we did it in class. People seem to be doing pretty good on the graphing. And the newer material seems to be the part that everybody wants to cover. So that's why I'm working backwards. Okay, so now number 18. So once again, the very first thing that you're going to want to do on these types of problems is go ahead and get everything broken down to its smallest factors so that you're ensuring that in that common denominator or least common multiple, however you like to think about it, so you're making sure that you're multiplying both sides of the equation of that. So the only one from here that really looks like it can be reduced further is going to be the 4x squared plus 12x, which is going to reduce to 4x times x plus 3. So that's going to be, so that's cool because we've got the 4x here and we've got the x plus 3 here. So the common denominator is actually going to be this one right here. So we'll multiply both sides of the equation by that. And the reason, once again, the reason why we do this is to eliminate the denominator altogether and get a linear expression, which is much more user-friendly to work out. So, like I say, we'll multiply both sides by that. And a lot of times just to ensure that we're canceling out exactly what we need to and multiplying exactly what we need to, I personally make it a habit to leave it in its factored form when I'm multiplying it out because it's a good reminder for me of what I need to multiply by as I take each step. Okay, so we multiply this side of the equation by that, and we multiply this side of the equation by that. So 4x actually goes into this 4x times x plus 3, and it actually eliminates the 4x and then gives us the x plus 3. And then x plus 3 times 1 is x plus 3 because I'm multiplying it by the numerator in order to get that piece. Once again, I try to keep everything in parentheses while I'm doing this step, just to make sure that I'm distributing everything where it needs to go. All right, the x plus 3 on the second fraction in the rational equation, x plus 3 will go into this common denominator with 4x left over. And then 4x times 1 is 4x. Equals, and then this 4x squared plus 12x is actually this whole big thing. So that goes into it one time, and 1 times x minus 5 is x minus 5. Any questions about that step? We good? All right, so now what I'm going to do is actually combine like terms on my left-hand side of my equation. So I've got x minus 4x, which is actually going to give me a negative. I'm going to write it up here. Negative 3x. And then I've got a plus 3 equals x minus 5. And now I'll combine terms on both sides. Trying to get all of my variables on one side of the equation, and then all of my constants on the other. So I'm going to subtract 3. Oh, this is a pretty one. We don't get a lot of pretty ones in Algebra 2, it doesn't seem like. Okay, so now we'll divide both sides by negative 4. And that should give us a positive 2. All right. Now, once again, this is one that we definitely want to go back. And I'm going to erase all this stuff around here. We want to double check and make sure that this 2 is not an extraneous solution. And in so doing, what we're looking at is plugging that 2 into the denominator to ensure that it doesn't cause a 0 in the denominator. And if I plug in a 2 in this first fraction here, 4 times 2 is 8. That's not going to be a problem. And then here we've got a 2 plus 3. That's going to give us a 5. That's not going to be a problem. And then here on this one, we've got 2 squared, which is 4. And 4 times 4 is 16. Plus 12 times 2 is 24. So 16 plus 24 is 40. So that's not going to be a problem. So 2 is a solution, and it's not extraneous. Does that make sense? Any questions about that one? We good to move on?
Yes.
Okay.
Yeah, there's nothing in the chat bar, so.
Okay. Did we have a few others join us?
We have like, let's see, 9 people.
Okay, cool. Hi, everybody. All right, number 17. And if somebody types it in the chat box, Adriana, if you'll just tell me, can anybody give a guess as to what the common denominator is going to be, where we'll multiply both sides of the equation by what in order to incorporate all factors?
Josh said 5n.
That's it. Absolutely correct. Good job. Okay, so the common denominator is going to be 5n. So we'll multiply. Oh, that's pretty. We'll multiply this side by 5n, and we'll multiply the other side by 5n. And we do this once again, just to reiterate, we're trying to eliminate the denominators, and you can do that by multiplying by the denominator, because then they cancel out. And this gives us a linear expression. A linear expression is just way easier to work with. So 5n goes into 5n one time, and then 1 times 8n plus 8 is 8n plus 8 equals. And then this 1 is actually expressed 1 over 1, and 1 goes into 5n times, and 5n times 1 is 5n. I hope that makes sense. I can write that out if anybody wants to see kind of what that looks like.
Can you write it out?
Absolutely. What I'm basically saying, that 1 would be expressed like this. Okay? And what you're doing when we're multiplying both sides by this 5n, you're actually, it looks like this. This is what it looks like written out. That's kind of what's going on in the background when I say, 1 goes into 5n. This is actually what's happening. That's really what's happening. When you multiply this guy by each one of these, that's what's happening. So this essentially reduced down then is just 5n. Is that correct? Does that make sense? Better sense or no?
Kind of.
Okay. This, obviously we're working with fractions here. So what you're going to want to do with that 1 is turn it into a fraction. And 1 turned into a fraction looks like this guy. And we are multiplying both sides of this rational expression by 5n over 1, where this is actually being distributed to each piece of this whole equation. And when it's being distributed, it's technically being multiplied by each piece or each fraction. So 1 times 5n is 5n, and 1 times 1 is 1. And when you reduce that, that's 5n, and that's where that comes in. And then this right here, this negative 1/5, what's going on in the background by there when I'm saying how many times will 5 go into 5n? It's back when we were originally doing the multiplying of rational expressions in like 5.3, I believe it was. This is what's happening. When I say multiply that by that, that's what's happening. And remember back then we would reduce, and that leaves you n. That's what's happening here. Does that help to see that? A little?
Kind of.
Because this piece right here is actually applying all of that stuff that we've kind of used throughout the chapter. And now we'll combine like terms. And now the goal, this was all to get us a linear expression, which once again is just easier to work with. So we're going to try and get our variables over to one side of the equation and our constant over to the other. So if I take 4n from the, or I can actually, since I've got a constant and a variable there, I can actually bring this 8n to the other side.
Let me have it.
No, I'm testing out the game to make sure it worked. I'm watching the math lab.
See my face.
You need to be taking notes.
You can't see my face.
This is the math lab.
Turn my face off.
Are you supposed to be taking notes in that class?
No.
I turned it off.
And you're not. You're going to be in trouble.
Okay.
Okay, so subtract 4n from both
Can I fix
sides.
it?
Okay.
4n
All right.
plus 8 equals 0, and then I'll subtract 8 from both sides.
115, got it.
4n equals negative 8.
Someone already gave the answer. I don't know if you want me to.
Oh, sure.
Evan said it's -2.
It is. All right, so now what you would want to do, once again, is just make sure that -2 is not going to be an extraneous solution. And it's not, because once I plug in that -2 with the 5n, it's just going to give me a -10. That's not a 0 in the denominator, so you're good. All right. So any guesses as to what the common denominator is going to be for number 16?
N squared.
N squared is absolutely correct. Good job.
Other people said that, not me, but like.
Okay, well that's fine. I appreciate you being the spokesperson for whoever said it. Good job. Whoever thought it and didn't say it, good job. All right, so multiplying both sides of the expression by n squared. How many times does n go into n squared? What would be left? So basically what you're talking about is you've got this. Whoops, my bad. So you've got n left over. So you got n. And then once again, the same exact thing is going to happen with this 4 plus n. Except in this case, you're going to have a 4 there because that's 4 over n. Right? So you're going to end with 4n. And now you've got this n squared going into n squared. That leaves you a 1. So then you've got 4n minus 3. And now we're going to combine terms on each side. Uh-oh. What happens? Anybody see what happens?
4n cancels itself out.
It does. Oh, well, but you got to add this anyway.
Right.
I just saw that other n. 5n equals 4n. I didn't see the other little n. And then I'm going to bring 4n over, and n equals -3. Then you would check that. Did anybody else write the answer before I got there, Adriana? Yeah. Okay. Then you would look at the n equals -3 and see if you plug it in to see if it's an extraneous solution by seeing if it makes that denominator 0. And it does not make the denominator 0 anywhere. So you're good on n equals -3. Those were actually easier than any of the other ones I think we've done.
Mm-hmm.
Don't you think? To me.
Yeah.
Some of them were a little more, detailed the other day. Whoever has their speaker on might want to turn it off. Okay. All right, moving right along to number 15. Now, this is where you're getting a common denominator on these. The biggest difference between 16, 17, 18, 19, and the ones where there's no equal sign, these down here are all equations where you can actually eliminate your denominator by multiplying both sides and making it a linear expression. On these up here, you're actually looking for an answer. So you have to get a common denominator. That's the biggest thing. So when you're looking at a problem, trying to figure it out, you want to hone in or key in on the example. Is there an equal sign in it? So that's one of the biggest differences. Okay, for number, once again, I'm just going to keep working backwards through the worksheet. So for number 15, we're going to get a common denominator. The first thing that you're going to want to do 9 times out of 10 is factor them. In this case, there's nothing to factor. So I'll just do these. Remember way back math lab last week where when I was doing these the first time, I make this really long fraction bar for each one of my fractions in order to incorporate what I have to multiply them by. So I know that's my beginning, and in order to have a common denominator, I have to include the other denominator. And whatever I multiply the bottom by, I have to multiply the top by in order to not change the expression. So I've got n minus 5 over here. And then I'm going to add or multiply n minus 4 and n minus 4. Whatever I do to the bottom, I have to do to the top so that I'm not changing the value of the fraction itself. Because when I multiply this by n minus 4 over n minus 4, that's really a 1. And when I'm multiplying the first fraction by n minus 5 over n minus 5, that's really a 1. So I'm not changing the value when I get a common denominator. So now what I'm going to do is distribute. And then that's going to give me 5n minus 25. And then I'm going to distribute a negative 3 to both numbers within the parentheses. And that's going to give me negative 3n. And then negative 3 times a negative 4 is a positive 12. And then that would go over our big denominator that we created, which is n minus 4, n minus 5. Then I will combine like terms. So 5n minus 3n gives me, and I'm going to write it up here, guys, 2n, and then negative 25 plus 12 is going to give me a negative 13 all over that big denominator that we created. So our final answer, because it doesn't look like anything's going to factor out, our final answer will be 2n minus 13 all over n minus 4, n minus 5. Or if you have that bottom, you know, those two factors can be written either way because multiplication.
Someone got the answer right before you said it.
Yay! Good job. Shout out. Good job. Way to go. I'm glad to hear that. Are there any questions about that? Anything pop up, Adriana?
Emily says no.
Okay. All right. Then I'm going to move right along to number 14. And once again, what we're going to do is create a common denominator. And that's on this, we want to factor. And once nothing here can really be factored. So we'll just create, we'll have k minus 4, k minus 1. And then we're multiplying this, the bottom, by k minus 1. So we have to do that at the top too in order to not change the value of the fraction. And then minus, and then 5 over k minus 1 times k minus 4 to create that common denominator. And once again, whatever you multiply by the bottom, you have to multiply by the top in order to not change the value. And now we're just going to distribute 4. And the key on the subtraction problems is to make sure you distribute this negative to both of these. So technically, you're multiplying a negative 5 times k, which is going to give you a minus 5k, and a negative 5 times a -4 gives you a +20. So that's the big thing of making sure when you're doing these that you don't forget to distribute that negative all the way through the parentheses. So now we'll combine like terms. We have 4k minus 5k, which leaves you a -k. And then you've got a -4 plus 20, which is going to give you plus 16 all over k minus 4, k minus 1, which is that denominator that we created. How we doing, guys? Everybody feeling pretty good about this?
Yep, so far everyone's feeling good.
Okay. Thank you.
No problem.
I appreciate you being my liaison.
It's no big deal.
All right, moving along to number 13. Really nothing to factor. So we'll just get that common denominator, which is going to be, we're going to start with 4 over n minus 5. And then we're going to have to multiply that by this other factor, n plus 1. And since we've done that at the bottom, we have to do it at the top in order to not change the value of the fraction. And then over here, we're going to have 5 over n plus 1 times n minus 5. And once again, we've done that to the bottom, so we have to do it to the top. And now we'll distribute. 4 times n plus 1 is going to give us 4n plus 4 all over the big denominator that we created, n plus 1. And then once again, be very cautious. You want to distribute that negative, -5n. 5 times, that's going to give you a -5n. -5 times n is a -5n. And then -5 times a -5 is a +25. And now combine like terms. 4n minus 5n gives you n, a -n. Plus 25 gives me a plus 29 all over the denominator that we created. N minus 5, n plus 1. Not too bad so far. They all seem kind of the same.
Miss Sparks,
Yes.
do you think you could do one of the problems that is from 5.6 that have like the ones with like the squared on the bottom and it's like really confusing? Can I show you it with my little screen?
Yes. Are you talking about 16, 17, 18, and 19?
Yeah.
Yes. I have done some of those, but I don't mind if no one else minds if I go back and try them again. Does anybody object? That's because those are always good to review. The other thing that I could do is perhaps pull some from the worksheets that we did have. Do y'all still have those in your possession?
There was a worksheet from like, I think it was when we were first learning 5.6. I don't know. I can show you what it looks like.
All right, let me switch back over.
I'm going to have to go, Miss Sparks, so you might want to appoint someone else to read the chat bar.
Oh, okay. Do I have anybody do I have anybody willing? Emily, will you do it?
I can.
Okay, cool. All right. Yes, I can go back and do one of those other worksheets.
All right.
How does everybody feel about going back to doing some of those, since those seem to be the newer materials? Everybody feeling pretty good about the adding and subtracting of the rational expressions?
Oh, somebody earlier said do 19, and then
Okay.
somebody said yes, that's fine to go back.
Okay. I can definitely do 19, and then I'll go back and
All
do
right.
some of those others. Okay. And I'm trying to figure out which one it was. Was it the one we assigned Monday?
I think it was it Tuesday's homework? I think it was Tuesday's homework. It was like assigned on Google Classroom.
Okay. I'll see if I can't pull that up and see if
All right.
yes, I think I know what you're talking about. And yes. But I will go back and do 19.
Okay. Sounds good.
All right. So, just like in the ones that we were doing where we're getting a common denominator, a lot of the principle is kind of the same of what you're doing, but the reason that you're doing it is a little bit different. There, you're just doing it in order to combine your numerators so that you can get an answer. On the equations, you're actually trying to eliminate the denominator in order to come up with a linear expression, which is just a little more user-friendly. Okay, so kind of your reasoning behind it is a little different. But what you're going to want to do, just on all of these rational expressions, the thing that you guys should think about first in your mind is making sure all of the denominators or the expressions are in their lowest terms, like that they're factored. So like that 3a plus 6, when I'm looking at it, I know it can be factored to 3 times a plus 2. And the good news about that is that tells me that this and this are going to be in that least common multiple or greatest common denominator, however you want to think about it, because basically what you're doing is figuring out the smallest number that I can multiply all these little binomials by. So if I multiply both sides of the expression by a 3, by an a plus 2, and an a minus 7, I will have incorporated everything that's here. Does that make sense? At least that piece of it. And by so doing,
They said yes.
okay, good, thank you. And by so doing, what you're going to do, what's going on in the background of this is that you're taking each one of these. So I'm just going to write it out so that y'all can see it. Way back when we were doing like 5.3 and it was multiplying rational expressions, you would get a problem, and this problem would look like this. Okay, it would look like that. And you all would be like, oh, okay, well, I factored this, and it looks like this. And oh, look, I can cancel this, and I can cancel this with that. And that leaves me a plus 7, or a times 7 left over. And I've got a 1 times a times 7 over 1, which is just really a times 7. So that's kind of what you're doing here. Or a minus 7. I can't even read my own writing. Please help me. Okay, does that make sense? Does that help clarify what you're doing? Or no? Did that make it worse?
I think so. Sorry, I think my voice is echoing or something.
Oh, okay. I hate that when that happens.
I thought somebody else was talking, but it was just me.
Oh, that happens to me when I'm doing it. So, welcome to my world. Okay.
Can you just like solve the problem? Because I feel like that might help me. Just
Okay.
like do the steps. I don't know if that will help me or not. I just
Okay.
feel like I need to see it.
All right. So basically what I've done is 3a plus 6 goes into that big thing over here with an a minus 7 left over, and a minus 7 times 1 is a minus 7. Then I've got a subtraction, and a minus 7 goes into this big thing over here with 3 times a plus 2. And then I'm going to actually put this in parentheses because I've got to distribute that minus. So 3a plus 6 is what's left over times 1 equals, and then a plus 2 goes into that, which I'm multiplying this side by also, just so that you know. You're multiplying both sides of the equation by that common denominator. So a plus 2 goes into that with a 3a minus 21 left over because I distributed that 3 to the a minus 7. And now I'm going to a minus 3a is a negative 2a, and minus 7 minus 6 is a minus 13 because I distributed that minus over to the 6 equals 3a minus 21. And now I'm going to bring over my, I'm going to get my variables on one side of the equal sign. So I'm going to subtract 3a from both sides, and that's going to give me a negative 5a minus 13 equals negative 21. And I'm going to add 13 to both sides, and that's going to give me, and that's going to give me a negative 8. Then I'll divide negative 5 by both sides. And that gives me a equals 8 over 5. You would want to plug in that 8 over 5 back into the denominator to ensure you don't get a 0 in the denominator, to make sure it's not an extraneous solution, because it would be extraneous if it makes that denominator a 0 because you can't divide by 0.
Some people were asking questions. Somebody said, when there is more than one group of factors, how do they cancel out? And then I think that was it, basically.
Okay. All right. When there's more than one group of factors, how they're canceling out is the one that isn't. Okay, so like on that particular one, the factors were this: 3 times a plus 2, because this thing right here factored into a plus 2. And then a minus 7. So when you take this and then you're multiplying each piece by it, they're canceling, because when you write this over 1 and you're actually multiplying each individual expression, which is what's happening, you're multiplying this 3a plus 6 because you're multiplying both sides of the equation. You're distributing this big thing to both sides of the equation. This cancels out with this, and that's left over when you multiply it by this first expression. That's what's left. And then you're multiplying it by the 1, which this was the original fraction down here. So if I distribute that big common denominator to each piece of that, that would cancel, just like it did back when you were doing rational expressions, multiplying rational expressions back at 5.3 or 5.4. So that's how it cancels out. Did that answer the question?
I'm not sure.
Okay.
It probably did, I think.
Or make it worse.
No, I think you were good. I think they're talking about like how to get rid of the I don't know. It's kind of confusing.
Okay, well, let's try to do.
You're good.
Okay, let's try to do 18. Okay. knowing the very first thing that you need to do is factor everything to its smallest piece, I know that I can factor out a 4x from here, and that's going to leave me an x plus 3. Well, lo and behold, good for us, that 4x is here, and that x plus 3 is here. So this thing right here incorporates both of those other two pieces of those denominators. So I'm going to multiply each side of the expression by 4x times x plus 3. And so I'll multiply this side by that. And I'll multiply this side by that.
Are you trying to get like your lowest, is it lowest common factor? Is that what it is? In the bottom?
Yeah, your lowest common multiple is what you're trying to get.
Okay.
Because now, good job. Great synopsis. So what you're going to do, and the reason why you're doing that is if I cancel all of these things out, it's only going to leave me with a linear expression, just a linear expression with no denominators to it. It's just a single line expression, which is so much more user friendly. So what you're doing is now I'm distributing this 4x times x plus 3. When I multiply that by 1 over 4x, the 4x's would cancel out and would leave me with that x plus 3. And I multiply that x plus 3 times the numerator. What's the numerator? It's a 1. And 1 times x plus 3 leaves me an x plus 3. And now I'm going to work with the second fraction in this equation, which is 1 over x plus 3. And if I'm multiplying the 4x times the x plus 3 times the 1 over x plus 3, the x plus 3's cancel, and it leaves me with a 4x. And then I've got a minus 1, if you will, because that's the numerator, times the 4x, because that's what's left after the x plus 3's cancel. And on the other side of the expression, the 4x squared plus 12x actually cancels all the way. So that leaves me with a 1 times x minus 5, which is just x minus 5.
That makes sense.
Okay, so x plus 3 times 1 times 4x is a minus 4x equals x minus 5. And then x minus 4x is a minus 3x plus 3 equals x minus 5. And then when I bring my x from here, I'm going to subtract x from both sides. And that's going to leave me a 4x plus 3 equals negative 5. And I'm going to subtract 3 from both sides. And that's going to give me a negative x minus 8. Divide both sides by a negative 4. And that's going to give me x equals 2. What you're going to want to do to check for extraneous solutions is to multiply or to bring that 2 in and replace it. And does that 2 make anything in the denominators a 0 in the original equation? And it does not. So you know that 2 is a valid answer. It's not extraneous. So you're okay.
All right. I think that makes sense.
Okay. How's everybody doing? Any other questions? Would you all like me to work some of the more difficult ones from the sheet that we did the other day? Or are you good? Can anybody tell me what the least common multiple would be for number 17?
They're not saying anything yet, so.
Okay.
Somebody said 5n.
And that's absolutely correct. Do you all want me to do that one? Anybody say anything?
They didn't say anything. but I want you to do it if you can.
Okay. All right. That's fine. Okay. So they have said that the least common multiple, or the greatest common denominator, or least common multiple, either one, is 5n. So you'll multiply both sides by 5n. And 5n goes into 5n one time, and 1 times 8n plus 8 is 8n plus 8 equals. Now, over here, I have a 1. And the denominator, like what you would do when it's a whole number, is obviously the denominator is 1. So 1 goes into 5n times. And 1 times 5n is 5n. So that's what's going to happen to that one. Minus, and 5 goes into 5n with n left over. And that's going to give you an n. So now you'll combine like terms. Eight equals negative 4n, because I brought my 8n over. And now I'm going to divide both sides by negative 4. And that gives me n equals negative 2. So you'd want to plug in that negative 2 just to ensure that it would not make the denominator a 0, and it doesn't. So you're good.
All right, thank you.
No problem.
Somebody wanted to do number 2 and 3, and then somebody else wanted to do some from the worksheet from Tuesday.
Okay, great. I will do that. So I heard 2 and 3.
Yeah.
All right. And those, I think, were graphing ones. Is that correct?
I'm not really sure.
Okay.
They just said 2 and 3. They just wanted to make sure that they were doing it right.
Cool. Okay, on 2 and 3, and those are definitely different from each other. Number 2 is what we call that simple rational function. And when it's simple, it's technically in this form here. A over x minus h plus k. That's that simple one. And I believe that goes back to 5.2. So the very first thing, and the thing that Miss Stone and I are, what we really want you to grasp out of this is the asymptotes. So your vertical asymptote in this particular case is going to come from here, your denominator, and that would look like this. X equals 1. Because when you pull it out, you're technically, if you will, pulling it out exactly how it appears, or it comes out as opposite. So that's x equals 1. So we'll want you to be able to show us on the graph, we'll want you to be able to write VA equals x equals 1. And we will want to see on your graph, and pardon my dotted line through here, we'll want to see that you know exactly how to graph that asymptote. An asymptote is somewhere that the graph, there will be a curve around it, but will never cross. And in this particular case, since there's nothing over here at all, there's no plus k, then your horizontal asymptote is going to be y equals 0, which technically is the x-axis. So it would go like that. So your graph then looks like this. Okay? That makes sense? Any questions?
I don't.
Oh,
I think that was good.
oh, I graphed. You know what? No one caught this, but I graphed a -1 instead of.
Oh, that's what they were just saying.
Oh, good. Oh, good. They caught it. Good job. Yay. I wrote it right, but didn't graph it right. But that means y'all know it if you caught my mistake. So that's good. Know it better than you think you do. So now it looks like this. Is that better? And yes, you would not want, oh, nice graph, Miss Sparks. You would not want your graph to touch the asymptote. That's kind of that point behind that one. Sorry about that.
That's okay. I think that's good.
Okay.
Somebody said that they wanted to see number 12.
Okay, and I'll do that, and I'm going to do number 3 while we're here, and then I'll skip back. I'll skip over to number 12, and then we'll work on that worksheet.
Oh, wait. Somebody said that when they did number 2 and they put it into their calculator, he said, when I put it in my calculator, it goes under the asymptote, and that's what confuses me. He goes, wait, under the line? I don't know.
Okay.
When I put the line on, like when I put it in my calculator, the like graphing line goes under the asymptote or the.
Okay. Let me make sure the big thing when you're plugging in these rational functions into your calculator in order to graph them, it is so very important to make sure you're using parentheses. And almost using too many is worse than using not enough. By that, I mean, I think when I plug it in and I'm trying to make sure that this is what I do, you know, you go to the y equals for graphing. And then let me see. I tell you what, let me go over here to Desmos and try to show you what I mean. So y equals, and then I would do something like this. You just want to make sure that you're putting in parentheses everywhere. Does that make sense? So you're really going to write a parenthesis, then write another type of parenthesis, then do your 2, then close the parentheses, do a divided by, another open parentheses, x minus 1, close parentheses, close parentheses.
He said it worked that time.
Okay. Never too many parentheses. All right. So that should help you. And like, that's really crucial, like on tests and things like that. So basically on number 3, if you're putting this into your calculator, you're going to want to do open parentheses, x cubed minus 2x squared, close parentheses, divided by open parentheses, negative 2x cubed minus 2x squared plus 4x, close parentheses, close parentheses. Does that make sense? Clear as mud?
I think that's good.
Okay. All right. So now, when you're finding the vertical and horizontal asymptotes for Miss Stone and I, because that's the part we're really, really checking. And those don't show up on your calculator, but they tell us if you really understand about graphing these rational functions. So you're always going to want to graph. And I say this, next year when you all move on to pre-calc, you're going to be learning about holes in these graphs and slant asymptotes and things like that. So it's really, all of that's very crucial in finding that. So you want to make sure, like when I'm looking at number 3, I'll be factoring out at the top an x squared x minus 2. That's what that would look like factored all over. And down here, I'm going to factor out a negative 2x x squared minus or plus 1 minus, oh, whoa, sorry, x, forgot my x, plus minus 2, which then would factor to x minus plus 2 x minus 1. Yes? Make sure I factored it right. So that tells me that my vertical asymptotes, you set every single factor equal to 0 for your vertical asymptote. So that tells me that my vertical asymptote is going to be x equals -2 and x equals 1. Does everybody see where I get that?
I think yes. They said
Okay.
yeah.
Okay, good. I don't want, let's see if Miss Sparks can graph these correctly this time. Okay, so x equals -2 is over here. And x equals 1 is over here. Now, for that horizontal asymptote, what you're going to want to do is use that sheet that tells us where you compare the degrees on the top and the bottom. And when the degrees are the same, which they are in this case, because we want to go back to this original expression and compare the degrees. When the degrees are the same, you're going to take the ratio of the leading coefficient. And the leading coefficient at the top is 1. Because the degrees are the same, they're both 3. And the leading coefficient is a 1 at the top, and the leading coefficient at the bottom is a -2. So that tells me that my horizontal asymptote is going to be y equals -1/2. Does everybody see that? That's going to be fun to graph.
Yes.
Just like that. Okay. All right. Now, I will let you know, and I'm just going to explain this. We're not asking you guys to know this on the test or anything like that. I just want to keep introducing the concept because next year in pre-calc, it will be there. See this factor right here? That -2x, you would actually set it equal to 0 also, and it would let you know that there's going to be a hole at x equals 0 because these two cancel. So that kind of lets the x's there not really cancel, but this one of the x's cancels with that one. So that lets you know there's a hole at x equals 0. But like I say, you don't need to know that for the test, but there would be, like when you were drawing the graph, there would be this hole here. And you can sometimes see it on your calculator, but not always. But the graph would look like this. You've got a solid line. It kind of looks like that with a hole at the origin. And then your graph looks like this. The main thing we're going to be looking for tomorrow is, can you sketch that graph really well? And can you draw these? Can you tell us exactly what the vertical asymptote is and exactly what the horizontal asymptote? Show those on the graph and then give us a sketch of the rest. You don't even have to show the whole. I'm just trying to make sure that you all are kind of prepped for next year when you do talk about it. Okay? So don't panic about it. Just making sure we talk about it. Does everybody understand what they'll be responsible for, though, tomorrow on the test? Vertical and horizontal asymptotes, and being able to show those as dotted lines on your graph and being able to get the graph kind of worked around it.
Yeah, they said yes.
Okay. So can anybody tell me, we won't graph it or anything like that, but anybody tell me what the vertical asymptote for number 1 is?
They said 2.
That's absolutely correct. How about the horizontal asymptote?
Somebody said -3 and another person said 0.
It is negative. It is -3 is correct. And that is because, and I hope y'all wrote this down on that note where the horizontal asymptote is. On a simple one where it's f of x equals a over x minus h plus k, y equals k is the horizontal asymptote. So it's whatever this little animal is right out here. When it's simple like that. When it's all complicated and has all this beautiful stuff like that, that's when you're factoring. When it's simple and looks a little more user-friendly, like number 1 and 2, it looks like that. Does everybody see the differences? Or was that confusing? We good? Should I move on? I feel like somebody, okay. And what number was it? Number 12?
Number 12.
Okay. Okay, on number 12, you're going to get a common denominator, which is going to be, and I usually, like I say, I do these great big long fraction bars, but I've got the 6 over, and then it's v minus 1, and then times the v plus 2, like that. And then whatever you multiply, sorry, I think I wrote this one too long. Oops. Whatever you multiply the denominator by, you multiply the numerator by, so you don't change the value of the expression. And then over here, I've got 6 over v minus 1. No, my bad. It's v plus 2. And then I'm going to multiply it by v minus 1. And then I'm going to multiply the numerator by v minus 1. So I don't change the value of the fraction. So now what I'm going to do is distribute that 6 here at the beginning. And I've got 6v plus 12. And then I'm going to distribute the 6 over here, which is going to give me plus 6v minus 6 all over the denominator that I've created. I'm going to erase some of this so I can work down. I hope I'm not messing anybody up by erasing that work. Hope y'all got it. But this way I can move down. Now you're going to combine like terms. And that's going to give you 12v, because 6v plus 6v, and then 12 minus 6 is 6. And so you can actually, oh, it's a plus 6, my bad. Because a positive 12 minus 6 is a positive 6. You could factor a 6 out if you wanted to, but you don't have to. If you leave it like this, it's perfectly fine. If you factor it, it's perfectly fine. We can see it both ways. If you wanted to factor it, it would actually look like this. But if you wanted to leave it in that form, it would be fine too. It's not going to be wrong either way, whatever you want to do. If you just want the extra practice factoring, that's great. Any questions?
I think that's good. I think we wanted you to do 6.
Number 6?
Yeah.
Okay. Which the good thing, I think if I'm remembering what number 6 is, the good thing about that is that's going to give you some of that practice. It gives you the concept when you're doing those rational equations of the canceling out. Because I think it's a multiplication one. Is that right? Yeah. So what you're going to want to do is factor first. Always factor whenever you can. Factor, factor, factor. So k squared plus k minus 42 should break down to k plus 7 to k minus 6 at the top there. That k squared plus k minus 42, that should factor to that. So this cancels with that, and this cancels with that. And this, we factored into that. So the only thing left is a 4. Does that make sense? Clear as mud or good?
I think it's good.
Okay. Any others that you guys want me to do before I move to that other worksheet? And I'm going to try to pull up that other worksheet.
They're not saying anything, so you're probably good.
Okay. Okay, can y'all see that? Okay.
Yeah, that's good.
Okay. Is there a particular one that you want me to do?
Yes. Can you do number 3?
I can do number 3.
Oh. And then somebody else said number 1 afterwards.
Okay. All right. Well, I'll do both.
Okay.
And number 5 was quite a humdinger too, so I'll do that one.
Yeah.
All right. So once again, one of the first things that you're going to want to do is try to factor things at your denominator so you can incorporate every factor and multiply each side of the equation by those factors. So I'm going to factor. X plus 3 is in its lowest terms. X plus 7 is in its lowest terms. But x squared plus 10x plus 21 is not. So when I factor that, it looks like x plus 7, x plus 3. So I will then multiply both sides of the equation by that. And once again, the reason why I'm trying to do that is to kind of eliminate the denominator so that I'm only working with just one very simple linear expression. So looking at that first fraction, 2x over x plus 3, I'm going to take that denominator, and how many times does the denominator go into this least common multiple? Well, the x plus 3's would cancel, and it would leave me with the x plus 7. Well, that x plus 7, I have to multiply by the 2x, by that numerator. So I'll have 2x times x plus 7. And now that second x over x plus 7, how many times does x plus 7 go into that? Well, x plus 7 goes into x. The x plus 7s actually cancel out, and it leaves you with the x plus 3 times x. So I'm going to open my parentheses to make sure I'm distributing that minus sign all the way through. And now on the other side, that obviously this x plus 7, x plus 3, if we're multiplying that side by that, that's that whole thing. So the denominator completely cancels out and leaves you with an x squared minus 1. Is there any questions about where I got that before I move on?
Not yet.
Not yet. Okay. So
good.
now I'm going to distribute the 2x to the x plus 7. So that gives me a 2x squared plus 14. And now I'm doing a minus x times x, which is going to give me a minus x squared. And then a minus x times 3, which is going to give me a minus 3x equals x squared minus 1. Now I'm going to combine like terms. I've got 2x squared minus x squared, which gives me x squared. And then I don't have anything else on this side to combine my 3x with, so I'm just going to bring it down. And then I've got a plus 14 equals x squared, minus 1. Sorry, that's a little messy. And then I'm going to bring my x squared over by subtracting x squared from both sides. That's actually going to make those cancel. And that's going to leave me with a negative 3x on this side. And I'm going to bring my 14 over to the other side by subtracting it from both sides. Does everybody understand what I'm doing, or is that skipping too many steps?
I think you're good.
Okay.
Nobody's saying anything.
Okay, so negative 3. Divide both sides by negative 3, and that's going to give me x equals 5. Did I do something wrong?
Yeah, I didn't get that for some reason. I think
Yeah, I didn't get that the first time I did it either, so I feel like I did something wrong. I hate that.
I got x equals -1 over 11. I don't know.
Yeah, that's what I got the first time too. So I did something wrong, but I'm going back through.
You're good.
Because the first time on my and I'm looking at all of my work, and if anybody else can help me find it, that would be great. X plus 7.
Angela said plus 14x, not just 14.
Bless them. Bless them. That's it exactly. Awesome. Thank you so much. Ugh. I couldn't even see it on my, I was like, okay, where did I do that? All right. Yay. Okay, I think that does that. Plus 11x. Those do cancel out. That's where we get it. Those do cancel out. So then I have 11x equals -1. And then x equals -1 over 11. So I hope what you see is you definitely have to watch for simple mistakes. I'm guilty of them every time. And it seems like I do them worse on when I'm writing on Math Lab than when I'm writing on a piece of notebook paper every time. Okay. And then somebody said number 1, yes?
Yes.
Okay. And thank you to whomever caught my mistake. Bless you. Stop me when you see them. Sometimes if I speak it, I do a little bit better, and I didn't really speak that one as well. Every little step.
You're fine.
Okay, so let's take a look at number 1 and figure out what would our least common multiple be, or greatest common factor, or greatest common denominator. What would the least common multiple be on that one? Because technically when you say least common multiple, what you're looking for is like the biggest number that all 3 pieces of those denominators are going to go into. So what would that be? Anyone writing?
6x squared.
Perfect. Good job. 6x squared. So you'll multiply both sides by 6x squared. So 6x squared goes into 6x squared with 1 left over. And then on this side, 3x squared goes into 6x squared, and there would be 2 left. And 2 times 1 is 2. And then minus an x goes into 6x squared and leaves you with a 6x left over. And so I'll subtract 2 from both sides. That gives me a -1 equals -6x. Divide both sides by -6. And that's going to leave me a positive 1/6 equals x. And you would want to make sure that 1/6 is not going to cause a problem in the denominator and make it a 0 for an extraneous solution, but it is not in this case. Everybody good with me moving to 5, or is there another one that somebody else would like me to work?
They're not typing, so I think you're good.
You're good.
5? Okay. Okay, so number 5, you're going to want to factor all of the bottom to all of those denominators to make sure that you're getting the least common multiple for all of them. So you would factor that 4x plus 28. And so that's going to give you a 4 times x plus 7. And then this guy right here actually turns out to be, I'm going to write it down here so that you can see it completely factored in steps. It's going to give you a 4 times x squared plus 11x plus 28, which then factors to 4 times x plus 7, x plus 4. I just wanted y'all to see that me working those steps out so that you could see where that came from. And then this factors to 2 times x plus 7. So, do I have any brave souls that could tell me what the least common multiple is going to be for each side of this?
Guessing 4.
4 is a piece of it. That's absolutely correct. But you'll want, I know the word least common multiple makes it sound like it's going to be small. But really, in all honesty, it's the biggest multiple that all of them can go into. So 4 is definitely a piece of it. But it's only one piece of it. You're actually, that's why I think the word least common multiple is kind of confusing. Maybe greatest common denominator is the better word. So thereby, what is the biggest thing that each one of these contain? So like they all contain a 4, just like he said. They all contain an x plus 7, so you have to include that. And they all contain an x plus 4. They either contain it, you have to include everything. So this first one has a 4 and an x plus 7. That second one here has the 4, the x plus 7, x plus 4. And then the last one has a 2, which is inside the 4, but it also has the x plus 7. Basically, what you're looking at is everything has to be represented in the least common multiple or the greatest common factor. Everything has to be represented there. Nothing can be left out. Does that make sense?
I think so.
Okay. All right, let me go ahead and rewrite the factors again of that. I'm going to write it in its factored form. Maybe that'll help. 1 over 4 times x plus 7. That's this same one in its factored form. And then you've got this one, which is 4 times x plus 7 times x plus 4 equals 3 over 2 times x plus 7. That's that same, this right here written within its factored form. And now what I'm going to do is multiply both sides of this expression by the greatest common denominator, which is this thing right here. And would you all agree with me that this 4 and this x plus 7 is somewhere inside this thing right here? And if those two cancel out, what is left?
It'd be x plus 4.
Okay, good job. So x plus 4 times 1 is what? X plus 4. Because I'm multiplying what's left times the numerator. Now, this next part right here, this 1 over 4x plus 7, x plus 4, that whole thing is represented there. Everything about it. So it technically cancels completely out, and you're only left with the numerator. And then on the right side of the expression, this 2 is in the 4 with a 2 left over. And I'm going to write down the I'm going to write down what's already there. That's 3, which is the numerator, times the 2 that's left over. The x plus 7 cancels out completely, but there's still an x plus 4 left. How was that? Is that confusing, or are we good?
I think you're good. It makes sense to me.
Okay, how about anybody else? Stop me if it doesn't make sense.
I think they're good. They're not saying anything, so they probably are.
Okay, all right. So now I'm just going to distribute and combine like terms and all that other good stuff. So I've got an x plus 4 minus 1, which is going to be x plus 3. And hopefully Miss Sparks won't make any simple math mistakes. 3 times 2 is 6. And 6 times x is 6x. And 6 times 4 is 24. I've distributed that all completely out. And now I'm going to get all my variable on one side and my my constant on the other. So I'm going to take a 6x and subtract it from both sides, which is going to give me a negative 5x. Negative 21 over 5. And that's your final answer. Is there anyone that you want me to do from the classwork review, from this, or from this worksheet or the homework or anything?
So far, you're good.
Okay. Did I have people drop out? How many have dropped out and come back in and all that good stuff? We have.
I think a few people dropped out, but a few people came back in too. So,
Okay.
Oh, Wesley said 2 or 3
On this worksheet, Wesley?
No, I was just saying 2 or 3 people dropped out and then came back in.
Oh, okay, I got you.
Sorry.
No, you're good.
Is there any other ones? Because I am starting another math lab at 1:30, but I don't mind keeping going.
It seems to be good because nobody's saying anything.
Okay.
So you're probably good.
All right. So I guess I'll end this one and start back up. Hey, Emily, you want to come back to the second one and be my spokesperson?
Maybe.
Bless your heart. I know you have other schoolwork to do. If there's no other questions for this one, then I'll conclude. Thank you so much, Emily, for being the liaison.
No problem.
Okay. And also another thing, if there's ever any other questions that you do need me to cover in Math Lab, y'all can always email me first. I won't ever say who emailed me questions, but that'll always be one that I can start with. You know, and that'll be like a first problem from here on out that I work with. So that's another way to do it. And y'all are most welcome. Thank you for coming to Math Lab, and I hope y'all have a blessed day.
Thank you.
Bye-bye.
Bye.